Let us explore the graph of the cosecant function. The graph of cosecant x is derived from the graph of sine x. Now let's start identifying the characteristics of cosecant x. Just like the tangent function, we can see that there are values of x at which the function cosecant x does not exist. That means there are vertical asymptotes at these points. We have pi, then here, another here, okay, and so on and so forth. So if you notice that we have vertical asymptotes at pi, 2 pi, 3 pi. So in other words, the domain of cosecant x, okay, cosecant x is the set of all x's such that x is not equal to n pi, where n is an element of the set of integers. Now, to get the range of the given function, cosecant x, take a look at this interval from -1 to +1, the graph of the function does not exist. So we cannot consider the set of real numbers as the range. So we have the set of all y such that y, take a look, the graph that is going down, we can say that y is less than or equal to -1, or y is greater than or equal to +1. Okay, this describes the graph of the other half of the graph, which are located on the upper portion. Okay. Now, since we cannot identify the highest and the lowest value, its amplitude is also not defined, just like the tangent function. For the period, let us see how many complete cycles can we have at a certain interval. So let's start here from 0. Okay, we can trace. This can be 1/2 of the pattern. Then this make it 1/2. So in other words, the period of cosecant x is also 2 pi, just like sine x. The general form of the cosecant function is given by f of x equals b plus a times cosecant of c of x plus d, in which c gives us the frequency, while b as the vertical shift, the movement upward or downward. If the value b is positive, then the shift or the graph is vertically shifted upward, while if the value of b is negative, there is a vertical shift downward. So the value of d will give us an idea whether the graph is shifted to the right or to the left. Now, to get the exact value of the movement to the right or to the left, all you have to do is to divide d by c. Now, a gives us an idea of the range, but it does not imply that a gives us the range. It gives us a description of the range of the sine function, in which we can derive also the range of the cosecant function. Now, what if there is a change in the value of a? So we have the green graph for g of x, which is cosecant 2 times cosecant x, while the brown brown graph corresponds to cosecant x. Now, as you can see, the domain is still the same. Okay, if we have here f of x, then we have g of x here. For the domain, we have the set of all x's such that x is not equal to n pi. Okay, now we can see that in g of x, there is no significant change in the domain, so same as the domain in f of x. So there's no change. What about the range? In the f of x, the range would be the set of all y such that y is less than or equal to -1 or y is greater than or equal to 1. Now in g of x, take note that here we have 2, then we have -2. So that means the range will change. So the range would be the set of all y such that y is less than or equal to -2 or y is greater than or equal to 2. So changing the value of a will cause a significant change in the range. Now what about if we change the value of b? So let's say we have here plus, let's have 3. So 3 plus cosecant x. Okay, so a change in b will have an effect on the range. The domain is still the same because its vertical asymptotes are still on the same position. Okay, so both will have a domain of the set of all x's such that x not equal to n pi, where n is an element of the set of significant change in the domain, but in the range there is. Okay, or in f of x, remember that the range is the set of all y such that y is less than or equal to -1 or y is greater than or equal to 1. Now in g of x, take note the range is the set of all y such that y is, for the graph that goes down, we will have less than or equal to +2, or to the graph that is going up, we will have y greater than or equal to 4. So take note that if there is a change in b, especially that it's positive, okay, originally we have here, okay, we have here, this is the range between negative, okay, this is the range of sine x. Now it's like it was moved upward. How many units? So let's see, from -1, we have 1, 2, 3, which is the same as what you see on the value of b. Now let's see the effect of changing the value of c. So this time we have cosecant 2x, which refers to the green graph. Okay, remember that the domain of f of x, okay, the domain of f of x is the set of all x's such that x is not equal to the multiples of pi, okay, where n is the set of integers. Now for g of x, do we have the same? Okay. Take a look that there is a movement on the vertical asymptotes. So let's graph the vertical asymptotes for g of x. Okay, so we have halfway between 0 and pi. Then we have here at pi, another here, then another here. So let's see. Let's identify those points. You can have a lot of vertical asymptotes. So here, this is pi over 2. This can be written as 2 pi over 2. Here we have 3 pi over 2. Then we have 4 pi over 2. Then we can see that at this point, we will have 5 pi over 2. Then here we will have 6 pi over 2, and so on and so forth. So if we consider these values, pi over 2, 2 pi over 2, 3 pi over 2, and so on, it's like we're dealing with the multiples of pi over 2. So that means our domain will be the set of all x's such that x is not equal to n pi over 2, where n is an element of the set of integers. Now for the range, we can say that there is no significant change. So it's still the same. Y is less than or equal to -1, or y is greater than or equal to +1. No significant change in the graph. For the period, okay, we can see that there is also a change in the period. So remember that in f of x, we have 2 pi. Now, in the interval from 0 to 2 pi, let's identify the frequency or the complete cycles in g of x, okay, on the interval 0 to 2 pi. So we have 1/2, okay, then another, so that makes us one complete cycle. Then here, one, another complete cycle. So therefore, in the interval 0 to 2 pi, there are 2 complete cycles. Hence, the period would be 2 pi over 2, and simplified will give you pi. So therefore, the change in the value of c will have a significant change in the domain and in the period. Now, what if there is a change in the value of d? So from 0, let's have -3. Okay, so the original function is this one, f of x. Okay, so as you can see, if we will select a point on the graph, so let's see, we have this at 1.5. Okay. Now, if we will have this point, okay, so midway, let's have, okay, getting the difference between 4.5 and 1.5, we will have, okay, 0, or -1, we have 3. So that means that a change in d will cause a shift to the right or to the left. Since we have -3, it means movement to the right 3 units. Okay, why do we have 3 units? C is 1, so -3 divided by 1, we will have -3. Now, since it's -3, that means the graph has shifted 3 units to the right. That's all for the transformation of the cosecant function.